The galaxy web is made up of voids, filaments, and nodes. Now the two structural elements are nodes and filaments. What are those made up of? Superclusters. Let's first take a look at superclusters. What are superclusters? Superclusters are basically what they sound like. They're clusters of smaller clusters. And clusters are in turn made up of groups of galaxies or just a collection of incredibly tightly packed galaxies. So let's get a little more into it. Let's look at the image that we saw of the galaxy web. So here's an image of the galaxy web, and what you're seeing here are nodes, filaments, and voids. The nodes and filaments are made up of superclusters, but just how big is a supercluster? So let's look at this image. You see that line, that white line.
That white line shows the distance, which indicates an indeterminate, as of yet, number. That's because of an ambiguity in the Hubble constant, which we'll learn about later. And that indeterminate number is somewhere between 166.6 and 250 megaparsecs. Our local supercluster, in contrast, is smaller than that. It's 153 megaparsecs. Our local supercluster is anywhere between about 2/3 the size of that line to almost the entire line.
And you'll see that that would have a number of nodes within it, that would have a bunch of filaments, and it would have some voids. And when we look at our local supercluster, that's exactly what we see. So let's look at our local supercluster. Here's Laniakea. Laniakea is our local supercluster. What is a supercluster? A supercluster is a collection of 3 to 10 clusters. It could be more, but usually it's going to be 3 to 10 clusters. And if you look at Laniakea, you can see a number of clusters. You can see in the bottom right the Hydra cluster. You could see in the top right a bunch of clusters, and so too with the left, the upper left, and the bottom left. And this is what superclusters look like. They look like collections of clusters. Now you could tell the shape of the universe when looking at this. You could see the filamentary structures. You could see a much heavier concentration, a node-like structure on the upper right, and a slightly node-like structure on the lower right. And other than that, you mostly just see filamentary structures connecting these nodes and going off of these nodes. So this large structure is a supercluster, but what's smaller than a supercluster? Smaller than a supercluster is a cluster of galaxies. And a cluster of galaxies, like you could see here with numerous clusters throughout, is going to be much less than 153 megaparsecs long. And in fact, clusters of galaxies will be filled with something between 100 and a couple of thousand
Galaxies.
And they're all going to be revolving around a central galaxy. And that galaxy is going to be an elliptical galaxy rather than a spiral galaxy. And that galaxy will be filled with very, very old stars. And it's going to be humongous. In comparison, when you look at smaller size things, smaller size than a galaxy cluster, you have galaxy groups and individual galaxies. In a galaxy group and individual galaxies, you'll never see this sort of thing. But when you see a galaxy cluster, the central galaxy there will be humongous, it will be elliptical, and it will be filled with old stars. Now, when we move down from a galaxy cluster, we could get to a galaxy group. And a galaxy group is anywhere between 2 and 50 galaxies, taking up a length of about 3 to 5 million light years. And that's in comparison to a cluster, which could have 100 to several thousand. But when a cluster has 1,000 galaxies, that will be within
20 million light years.
Or just about. If you were to multiply groups to reach 1,000 galaxies, you'd fill up a lot more space. So we have clusters and superclusters, and then we have groups underneath, which are some 3 to 50 galaxies, taking up some 3 to 5 million light years. And then underneath that are field galaxies, which are individual galaxies,
which are found loosely in space, not associated with any given group or cluster.
And there are two things that we're mentioning now. The first is, well, what are galaxies? Because that's what all of these things are made of. The superclusters, clusters, and groups are made up of individual galaxies. So what are those? What kind of shapes and forms do they take? And we're going to look at that next. But first, and to close off this video, let's address the fact that the image of Laniakea isn't actually a neat fit with the image of the galaxy web, as I showed you. The galaxy web, in fact, looks a lot fuller. If you look at a node on the galaxy web versus a node in this image of Laniakea, it's much denser. And same thing for the filaments. The Laniakea is almost like just a sparse distribution of specks along the filament and
within the nodes.
And that's exactly right. The model that we're looking at over here of the galactic web is actually showing dark matter. Dark matter is a subject on its own, and I'll address that in another video. But that's the majority of the matter that we're actually seeing, and that's what's making the shape of filaments and voids. And you can understand from that what cosmologists mean when they say that regular matter, that the galaxies and superclusters of galaxies that make up our universe are nested in a halo of dark matter. They're surrounded by dark matter. And not only that, but the matter that we're seeing when we look at the stars of the galaxy is significantly less than the matter that you're going to see in a galaxy writ large, which is going to be mostly, aside from the dark matter, gas and plasma. Until next time, when we talk about galaxies. Cheers.